Somebody remind me the definition of logarithm.
I could tell you.
Tell me.
G of x equals a. That's the definition.
No, Kira.
B to the x equals a, which means x equals log base ba.
B to the x equals a
And then
is
your
equivalent
double
to.
ants, yeah, arrow thing.
Yeah.
What point two?
Okay.
X equals log base ba.
I said that.
Yeah. Hey, you forgot your x equals. Just
That's actually
thanks.
pretty important.
Okay, so here's a little trick. If you so like can you see that you're kind of swapping these around?
Yes.
Does it look like you're swapping these around?
Yes.
So b is always your base. So this is a base of an exponent. This is a base of a log. So b doesn't move. And the way we write the logarithm, this a little bit looks like an exponent, right? It's not an exponent, but it looks like an exponent, right? Warren,
Yeah.
Eric, are you with me? Kind of looks like an exponent. This is a base. This is log base b of a, but you could kind of just think of it as swapping those two around and like writing log if you don't have log or erasing log if you do have log. Does that make sense?
Could you explain where like log comes into play? Like, what do we do with log?
Like where does it come from? What do we do with it?
Like, what do we do with it?
I'm going to show you. I'm going to show you many examples.
Okay.
But I just wanted to write that down. We wrote that down last time, and it seems weird and confusing, but that trick might help you. So it's for now it's just the pattern, right?
Wait.
Wait.
Yeah, wait.
When do you use log?
What happened to your clock?
What is log? Yeah, I can't fix it right now because I'm recording. If people bump it, it gets a little wonky, but I can fix it on my computer. But I'm recording right now. What is log? What is log?
I don't know what log is.
What is
but I know
log?
how to do it.
Logarithm is what?
The inverse of an exponent.
Inverse of exponent. So what? Explain to me this operation. What do I cancel?
3
What does it give me?
x.
Y? Y?
Because it's logarithm.
It has nothing to do with logarithms.
Oh no.
What is this operation?
Division.
Multiplication.
3x is not division.
That's what I was talking about. The 3x divided by.
This one, look at my arrow.
Multiplication.
Multiplication, what is this one?
Division.
And multiplication and division are
Inverses.
inverse
Oh yeah.
operations. Multiplication, division.
Wait, so every time you told me to do it, the exponents of the 1/3 instead of doing it like because I had to undo it, I could have just been doing log.
No.
Oh.
What?
Then how do you use log?
I'll show you. Explain to me this. What do I get? How do I simplify?
X.
I would
X, Y
'Cause
5 minus 5
is 0.
0.
And addition and subtraction are
Inverse.
inverse. What?
Operation.
They're inverse operations, plus and minus. So if I have x to the 7th, and I take the 7th root, what do I get? X, right? These cancel. These cancel. Why? What's happening? It's not division.
Inverse log.
It's not an inverse. It's not a.
Squaring
You're guessing.
to an exponent and the root of that exponent.
Exponent and root. Exponent. Let me not write it that way. Power. Let me write it this way. A to the b is the what is the inverse operation of a to the b?
A to the b root.
Yeah.
A to the 1 over b.
Oh.
So that's like a power. That's like powers that are inverses. So if I have like this leads us to like an inverse property. So let's say inverse property. If I have log base 2 of 2, what does that give me?
1.
If I have log base 10 of 10, what does that give me?
1.
Okay, so in general, log
Wait, why do you write the smaller one all like? Wouldn't it be like the opposite? Wouldn't the bigger one be?
Huh? What?
Like the one right next to log is like really small, and then the one.
That's the
right-
base. So this is log base 10 of 10 equals 1. This is the base of the log. This is all part of it.
Oh, okay.
What if I don't specify log? What base am I assumed to be using?
1.
No, there's no such thing as log base 1. Log base 10 if you don't say the number. If you leave off the number, it's log base 10.
Why?
If you don't, it's a shorthand because we use log base 10 in science and engineering all the time. So that's just a shorthand. If it says log, it's log base 10. If it says ln, that's the natural log. It's implied log base e.
Will you not give us the log base and we have to be like, oh, it's
No, no.
Yes, you all have to know that. It's a convention. Log base 10 is if it's you can specify it, but if you leave it off and you spell it log, that's log base 10. If you spell it ln, that's natural log base e. But what was this? I'm not done writing my inverse property.
Equals 1.
Log base b of b to the x.
Equals 1. Or does it equal x?
It's x.
X equals
Yeah.
implied 1.
Yeah, down here it was 10 can be written 10 to the 1. That's where that 10 comes from because this cancels. I mean, that's where that 1 comes from. 2 can be written as 2 to the 1. This cancels, that leaves the 1. That's why that does that.
Oh,
Because log and exponentiation are inverse properties. So I should write this down too. So exponent and log are inverse properties.
so if you're using an exponent and you want to get rid of the exponent, you would use log.
Right. Leave your phone.
But so how can you tell when, or like, how do you know when to, like, do the root of something or use log? Because, like, power and exponent are almost the same. Like, they're referred to as the same.
Right. So if I have x squared, what's the inverse of x squared?
Square root.
Square root, or I could write this x to the 1/2.
Yeah.
If I have 3 to the x,
Okay, then it's
you notice where the x is?
in
So
the
so we're calling this a power,
Okay.
and we're calling this an exponent, exponentiation, because the variable is up top.
Okay.
Right.
Can we do a practice one?
We'll do a bunch, but I'm going to write down a bunch of rules and stuff that we have so far. This is also an inverse property. So if I just like if I say 1/3 x times 3, that's just like a rearranging of those inverses. So if I say a to the log base a, of x.
Okay. Oh, so it was on the notes.
What's that?
This was on the notes. You get X.
You get x. This is like multiplying first and dividing second compared to multiplying second and dividing first. You know what I'm saying? So the order doesn't matter. They're inverses. So a to the log base a of x is going to give you x. That's going to cancel. Log base b of b to the x is going to cancel. They're inverse properties. Somebody tell me what the one-to-one property is.
I think I know it.
Okay,
Like for
go Warren,
logarithms,
go.
like the arguments are equal to each other, like when the base is the same.
The bases are equal. The
Oh.
bases are equal. So if I say a to the x equals what? You said the bases are the same.
Yeah, like so like a, like a random number.
No, the bases are the same.
Okay, so like
A to the
a to the
something else.
y. Yeah.
If and only if. Are you okay if I use that abbreviation? If and only if?
Yeah.
If this is true, if and only if what's true, Sydney?
If and only if a equals y, x equals y.
X equals y. So x equals y. So if the bases are the same, you can just bring down the exponents and set them equal to each other, because this is an equality only if and only if those are equal. Okay, so here's another one that we haven't talked about yet.
Oh, we did this last class.
Maya, you wanna help me finish this one? Annabelle?
No, I'm good.
It's the same principle. Same idea.
X equals y.
This is only true if x equals y. So I have a log with the same base. And so this can only be true if x and y are true, are equal.
Why'd you say if with two? Is
If
that
only
for dramatic
If
effect?
and only if.
Is that for dramatic effect or is that?
No. It's an abbreviation.
Oh.
If
Oh, if and only if.
how could I solve for x?
Probably logarithm.
How could I solve for x?
You do log 2.
No, I'm not going to even use logs. I don't need to use logs. I get an easy out. I could do logs. I eventually will do logs.
Isn't it equal 32? Isn't x equal 32?
X is 6. X is equals 1. But wait, because if 32 is... oh, do you need to...
X
make
equals to
32...
5.
No, you need to make 32
Where
to
is
a power
y?
of...
That makes no sense.
No, 2. We need to make 32 2 to the power of something. Which
Okay,
is
so if I
5.
rewrite it as 2 to the x equals
2 to the 5, I think.
so if you're doing powers and you're not sure what is equal to what, you can just make a little table. So 2, 4, 8, 16, 32. What powers are those?
2.
1.
2 to the what is 2?
1.
2 to the what is 4?
2.
2 to the what is 8?
3.
2 to the what is 4? Is 16. 2 to the what is 32?
5.
And we're done. But you can keep going.
What happens if you just don't know that off the top of your head?
So I'm doubling. I'm making a table. If I didn't know it off the top of my head, I just double it. 2, 4, 8, 16, 32, 64, 128, 512, 1024, 2048, 4096. So what is x?
I think it's 5.
What is the property?
1 to 1.
So we're just trying to find the exponent.
Solving for x. If I have this equation,
Oh, I'm trying to.
Sure, maybe go to the bathroom.
yeah, leave your phone. What can I do to try to solve this?
Is that just LN or like?
Yes, that is, if instead of writing log base e, the abbreviation for that is ln, natural log,
Which is
log base e.
yeah, but LN. Can we on the calculator we click second LN
Yeah.
and then we get E, right? Yeah.
Second ln was e to the x.
No, you just press L and
Wait, what is LN equal?
It's the base natural log, but I don't really need that. I could have said log base 13.014 of x minus log base 13.014 of 3 equals 0.
Oh, x equals 3.
Let's rewrite it. Let's rewrite it real quick. What's on the right side? Eric?
Oh.
But is it natural log
Right
of
side.
10?
No, that's only if you're not.
I need you to follow along with class and not drift.
I know.
Your imagination is drifting.
I know x equal to 3.
What's on the right side when I rewrite it?
I and 3.
It's natural log.
Natural log.
It's ln, natural log 3. And then x equals? Carlo?
The third?
Using what property?
The 1 to 1.
1 to 1. I would have solved it the same way with a crazy base that I didn't really know how to use.
There's so much going on. Do you understand?
What do I want to do to solve that? E to the x equals 7.
But like,
I don't know if 7 is a power of e, so I don't think I'm going to rewrite this. I think I'm just going to go ahead and resort to log. What log? Which log do I want? If I have e as the base of my exponent, which log do I want?
natural.
Natural log. I'm going to take natural log of both sides.
Wait, can we just use log anyways? Everything?
Yes. But sometimes you don't have to. Sometimes it's a power and you can use 1 to 1. 1 to 1 is actually a shortcut.
I'm confused about the natural log.
So we have different. We can use different bases. Just like you have different numbers that you could raise, that you could exponentiate. So to undo those, we would want to use logs of different bases. So these are different bases of the exponent.
Mhm.
So we would want to use logs of different bases to be the inverses of those. Okay, so what do I do now? Oh, I messed up my columns. So that was my original equation. Here's my rewritten equation. And Carla, which magical property of logs or exponents do I use?
Inverse.
Inverse property leaves me with what?
I don't know.
What does the inverse property let me do? Cancel, right?
Yeah.
What can I cancel?
The exponents.
So ln is log base e of e to the x. That leaves what on the left side?
Oh, X.
So I just put it in my calculator.
Wait, could you go over one more time how you got from the rewritten to the?
Solution?
Yeah.
Oh, what was the property, Carlo? Yeah,
The inverse. Property.
inverse property. So so this is the first time you're seeing me do this, but we're gonna do it a bunch. Is I have something raised to an exponent. I mean I have a variable in the exponent, and so I want to take the log of both sides. So that's what I did. Took the log of both sides. Then that allowed me to cancel the exponent on the left side. I didn't cancel it on this side. That left me with a natural log of 7, but I would just put that in my calculator.
Oh, okay.
So I don't know how to put this in my calculator. E to the x equals 7, but I can definitely put this in my calculator.
Got it. Okay.
All right, so for 5.2 homework A, here's a couple of tips and tricks. So with definition of logarithm, how would I rewrite, let's see, Charlotte, help me with number 7. Using definition of logarithm, how would I rewrite that logarithmic statement?
Into the first, or okay.
I want to it's a log statement. I want to rewrite it as an exponentiation statement.
Yes. Okay. So it would be 4. Wait, I lied. Okay, wait. It would be 16 equals. What is 4?
So the base is always the base.
Uh-huh.
Oh, sir. I do. You know, I stopped by and no one was there.
I haven't known you before.
Okay. Sure.
Oh yeah. Sorry. I see. Okay. Okay. 4 equals.
Not 4 equals.
Sorry. 4 to the second equals 16.
Right. This is our trick, right? So I'm leaving the base alone. I'm deleting log if I have it, or I'm writing log if I didn't have it, and I'm swapping these two. So let's swap these two. Maya, do the trick. Make it happen. Log base 5 of 125 equals 3. That's it.
8.
That's exactly right.
I taught this
Is
to
this
myself
gonna be
the
like
other night because I missed
I mean,
class. Like
our
we were
homework?
recording, so I just tried to teach how to do log from
Is this the
thing.
homework?
This is
Yeah,
this is
it's
from homework.
5.2a. There's
Also,
one-
when you get to number 7 on the homework, don't say did in class, please.
Why would you
Number
do that?
11, don't say did in class. Believe me, I've seen that. I've seen people do that.
you literally just plug it in. I was like, I don't know how to do this. And then I was like, fine.
All right. So there's a section that says do this without a calculator. So if I say f of x is log base 2 of x, and I want to find f of 64.
Log base 264.
So far, so good?
Um,
Now what?
can you
Eric.
rewrite it?
Eric, what now? How do I solve this without a calculator?
I don't know how to put in a
No, without a calculator.
Oh, without?
Yes, you're doing this without a calculator. You can verify your answer with a calculator, but I need to see all the steps of you solving it without a calculator. Warren, what can I do?
Log base 2 of 64, so that's like express 2, like express 64 as a power 2, so that's gonna be like 2 to the 6th, I think. Yeah. Awesome.
Gives you what?
6.
That's how to do that without a calculator. By the way, there's no log base 2 button on the calculator. All right, so then in the next section it says use calculator. So if I have f of x equals log of x, what base is this? Carlo. It's log base 10. And so we're actually going to use the calculator. So let's look at the calculator. So here's my log. That's base 10. Here's my ln. That's base what?
Base E.
Base e. So if I want to do log of, what was it? 7/8. And if I wanted to,
Get a negative.
it's less than 1.
Oh, right. Okay.
Yeah, it's less than 1. No, sorry, it's less than 10. Log base 10 of log base 10 of 10 is 1.
Okay.
It's negative because it's less than 1. Yeah, that's right. So if I wanted you to show that to 3 decimal places, Annabelle, what would it be?
You want to do this 3 decimal places?
Yeah.
Negative 0.57 or 58.
Well, Kira?
I'm not sure if I heard her right, but I thought she skipped a 0.
It's negative 0.058, right?
I meant to say that. Negative
Oh, you skipped the 0? Yeah.
Negative
0.058, right. Yep. Do y'all have any questions? Because that's all I have for you.
Is it all of 5.2?
No, we're not done with 5.2.
What's the difference between base A and base B? I roughly followed, but I didn't really understand.
It's a generic way of writing it.
Oh, okay.
So I'm just saying, no, there's no difference between base A and base B. So, I mean, that's just 2 different generic ways of writing it.
Okay.
It's a variable. So we've talked about log base 2, log base 10, log base e.
Yeah. Okay.
So this is writing it in a general sort of way. So it doesn't matter what the base is as long as the base is the same.
Oh, I see.
Do we have this tonight?
Yeah.
Homework.